it will be important. So before we see the code, let's see what we are going to do. Okay, what is the Fermat-Macbeth as a procedure and to see some details. So it is called Fermat-Macbeth 1973, was developed by these two in early 70s. Remember what we said about panel last week? We have a panel regression, and with the fixed effects, if you remember, and the time fixed effects, we are able to allow the model to run by allowing the constant to change for every firm, or the time, or the constant to change for every time period, okay? But to allow the slope variable, the coefficients to change for every period, was not able to do it. It's not able to do it in panel with fixed effects, okay? So the idea with the Fermat-Macbeth is to allow the regression to get different coefficients every time. Cannot do it with a simple regression, with a simple one run, so we need two-stage regression. And this is the Fermat-Macbeth, okay? It is a two-stage regression. And let's see an example, okay, that is very specific to what we are going to do, okay, to understand it. Okay, in the first stage, let's say that we have to run a regression model of this form, okay? The regression doesn't need to be only this. The regression can be general, whatever, okay? One y, many x, the timing can be any, contemporaneous or not, okay? The procedure is flexible and more general, okay, to run as a two-stage for any kind of regression, or also for portfolio we use a similar approach. But let's see how we run this for our model, the model we are going to do also in the coursework, at least a part of it, right? So the model we have is the return of the firms as y, and the returns are set at t plus 1, and the x variables at t. So the model we see and the table we have seen in the Baumeier-French 1992 study that I will show you later, the table 3 runs this model. The y is 1 month ahead. Okay, and the interpretation is different if it is ahead. It's not that this is related to a return, but it's related to subsequent return. Or this explains subsequent return, okay, not simply return, right? We will see the interpretation at the end. So the first thing is the first stage, since we have the model and we calculate and we prepare the x variables and the y variable, we have everything ready, we run this regression for every time step, for every t. Okay? When we run every time, we collect the coefficients from the regression. Okay? So if we do this, this is what we get. For every time step, for every t, we run this regression and we get the corresponding coefficients. We also, because every regression has also the R squared and the number of observations. All right, so this is the first step, the intermediate step. Okay, as we see at the end, we don't get this output, we don't see it, okay, when we finally we will run our code, we don't see this output, but this is actually behind it, right? Then, what we get from the final output is what we do in the second stage, okay? What is in the second stage? In the second stage is we get the average of each column. So this is the time series average of this variable. This is the time series average of this column, of this variable. So what we finally report and what we finally get from the code I will give you is the coefficient that is reported is the average of all these coefficients, of all these numbers. For each variable we have the average. So this is what we get here. Ignore the three models. Our model actually corresponds to model 4. So what we get for each coefficient, we get the average value, right? The average value. So the 21.74, so this value, the average of delta 0, it is the average of this column here. If you take the average of all these coefficients, you will get the 21.74. Or the average of this is what we see here, the 0.96, this value here. Okay, this is what is reported also from the codes we have, the outputs. Now, what is not straightforward, okay, is the standard error, the t-statistic, and the p-value. Remember I said that all of these three provide similar information, right? What is the t-statistic? The t-statistic is the average divided by standard error. And the p-value is the probability, the t-statistic to be higher than the critical value. So, whatever you have here, okay, standard error, t-statistic, p-value is the same, okay, provides similar information. Many times I say that I prefer the t-statistic because it's more informative in the sense that the t-statistic gives you the strength of the significance. For example, anything more than 4 has a p-value 0. So I want to know it is 0 because this is 4, 10, or 100, right? So this is why I prefer the t-statistic more than the p-value, but okay, it's up to anyone can use any of these. I was saying that the standard error we see here is not the average standard error from these regressions. Because, why I say this? Because, yes, in every regression we can also get the standard error and the t-statistic for each coefficient. We don't keep this information, we don't want it, okay? It's not the average time series we report, okay? The t-statistic we report here is found as the standard, from the standard error of the average. So we take the average of this column and we calculate also the standard error of this column. So the t-statistic actually is the t-statistic that the mean is of the hypothesis that the mean of this is 0. Okay, is not. I'm not sure if you understand this. We talk about it in week 3 or 4, but it's important to understand that the T statistic we report is not the average T statistic. We don't keep the T statistics from the internet, right? The other important to mention here is the interpretation of the output is as usual, okay, in any regression. So a coefficient of the size minus 249 means that higher size, one unit of the size, explain negatively the subsequent returns. Okay, how by minus 2.49? So 1 unit increase, minus 249 decrease in subsequent returns. Okay, always the interpretation is like that. In this PowerPoint, if you go through, okay, you will find other nice discussions about the interpretation. You may need, all right, I will close it. You may need it in the essay, possibly. So if you want to see how you interpret the result. And the R square that is reported here, yes, this is the average R square from all the regressions, right? All right. Let's go back to the code now. All right. So the first, we run our code. I want to open the data set we prepared in weeks 4, 5. Okay, the data set with a constant and crisp merge in a monthly format. Okay, so this is the code to the use code to open this file. Okay, this file, of course, remember when I did it, I downloaded only data sets from 2015 to 2023. For the project, of course, we need to take the longest period, so we need to re-download everything and rerunning the code, okay, for the merge file. Then, if you have the codes, if you have the data set, the first thing you have to do is to handle some data. Okay, you need to do the filterings with you see in the pages, right? So the first you do is to remove, usually we do this, we remove financial utilities. Okay, how we do this? How we remove financial and utilities? We have this SIC code. This is the standard industrial classification code. Okay, every firm has one unique SIC code. If you are, for example, operative builder, you have this code. If you are in meat packing plant, you have this code. So we know that financial have a code from 6,000 to 7,000. Okay, so if you are in a national commercial bank, you have this code. If you have trust or banks, you have something that starts with 6. And if you are utility, like gas or electric service, you are something in the 49, okay, queue system. So for this reason, we have this drop command that we have seen again, and using the if, we remove the first with SIC. How I find the SIC? The SIC is provided by CompuStat. This is the variable we had at the end, that it is the SIC of each firm. Okay, so hopefully we know the industry of each firm from CompuStat. So we use this SIC. Put this up. Very weird. So we have the SIC. And using the command, we remove this. So we run it. And you see, we drop this observation, right? Next, okay, all these here you see them as green is because our comments are not executable commands. Then one very important command that we need in panel analysis is a TS set. Okay. The TS set command is used in any panel analysis. Okay, this is to say to STADA, to set in STADA that the panel you have to use is defined by the per no variable and the YM variable. The per no, the first is to understand how to identify the cross-sectional variability, and this is using the per no. So it's not a country, it's a firm, but it's a cross-sectional. And the YM is to set the time series variable. Okay, in our case, it's the YM that takes every month one integer, right? But in order to run this, we need also to sort by these two variables, so the sorting command goes together. And if you run this, then STADA clarifies that the final regression is per no, and the time variable is a YM. Okay, and that the YM spans from 60 to 772. This is important. This definition is important. Why? Because we will need, it will be needed if you don't say what is your panel, you cannot run the Fama-McBeth regression, or you cannot run a panel regression. But it is also useful. Now we will see a nice command to generate a variable. Okay, now it's time to create our variables. what I mean. Need to create the variables in order to run this regression. Okay, so we need the x variables and the y variable, right? So we need to go one to one to create them. So in order to create the y variable, that it is the return one time ahead, we use this command here, the F command. Okay, the F command dot the variable we want to create actually generate a new variable with the forward return. If you use F1 is the next month. If you use F2, 3, F10 is 10 months ahead. All right? And of course, Stata can do that because now knows what is the time series variable. So when you say one here F1, it will go to bring the next month variable in front. Okay? So let's see. So if I run this, and let me put them together to so you see them here, these two. This is the one I created, okay? So you see that this variable comes here. And this variable comes here. Not this variable. This number goes here. This number goes here. Okay? So this is the F red. Okay? Why this is needed? Because we say that we want to run this with this row x variable. Let's say that the x variables are here are in this row. So I want to run this with this row. And we cannot do it that way. We need to create a new variable to be on the same row. So we need to put it here. So now you can, when you run this with these x variables, it's like you run the x with the head. Right? So this is why we create this f red. And there is also the L command. The L function is for lags, the opposite. Okay, L1, L2, when you want to create lags. Then we continue since we created our y variable to create our x variable. Okay, first we create the size, the size, but in order to create the size we need the market equity. The market equity is the price multiplied by shares outstanding, okay? The market capitalization. And we prefer to use the crisp items to calculate it because it's a market based and it changes every month. All right? We don't want to use the CompuStat item because we have also the corresponding CompuStat shares outstanding and price, but I'm not changing every month. Right? So we prefer this. Why I use absolute price is not weird. Since price is positive, why I use absolute price is because CRISP puts negative price where there is no trading. All right? In order to understand that it is not trading, so to avoid such negative values, we take the absolute in order to keep it positive, right? It doesn't matter for us, to us, if it is no trading. What is the price on that month? So we take the absolute. And we divide with 1,000 because the items increased are in thousands, okay? Chris provides the data, if not prices or dividends or something, in percentages, in thousands. For example, the shoot is given in thousands. So this multiplied by this will be 1,000. But all composite items are in millions, right? So in order to have all in millions, we need to divide this also by 1,000. Right? Then, since we have this in million as well now, the size usually is in logarithmic form. So we take the length of the market equity. The book to market can be calculated in two ways, at least. Okay, one is using the per share variables. The PKD LPS is the book value per share. I divide it by the price per share, or using the million equity value divided by the market equity. The two are very similar, very, very similar. And the net, the earnings to price is, as we see in Farmer French, if we go to Farmer French, the definition of this earnings to price, there are two dummies, okay? This and this. This dummy, as it is explained here, is if the earnings is positive, or the earnings to price is positive, this is just the ratio, earnings to market, okay? And if it is negative, it is zero. The other variable, this one, the dummy, if you read here, it is 1 if this is negative and 0 otherwise. Okay? So this is what we do here. First, we create the earnings to price, that it is net income to market equity. And then we use the generate again and the replace functions to adjust this variable. So first we create the earnings to price positive. This is actually to create this first. So my first variable is earnings to price, and I call it P for the positive. So this is the earnings to price as it is defined, if the earnings to price is positive, but replace the same variable with zeros if this is negative. Okay, we use the replace because we cannot use again the gen, because once this is generated, cannot use again the gen with an existing variable. So we need to use the replace to adjust it. And then we have the other variable that takes 1 if it is negative and 0 if positive. So it's the opposite somehow. Not exactly the opposite, but you are not wondering what is that, right? I see you just see me, you have no questions and worries, right? There are so many uncertain things. Anyway, the reason we have this is because the STADA, okay, handles the missings. Remember, the missings in STADA is with dot, okay? So the dot in STADA goes with the higher value. So, for example, here you say put 0 if this is higher than 0. In this statement, it's also the dots. So if you are dot, you are considered a very high number in STADA, in the 2-digit computer science engineering team, right? So if you are dot, you go together with the high. So if you are dot missing, you will get 0 with this command. So we don't want you to be 0. We want you to be dot missing. So this is why at the end we come back and we make it again missing. Okay? If it is missing, make it missing. This is standard what I show here. When you have if statement with high, low, usually at the end we come back and we correct this issue. Because it is a technical issue, not and since now we have the variables, we want them for the regression, then we use the regression command. Here I give you 2 commands for Fermat-Macbeth. I don't say are the only, maybe there are more. This is the one I know many years. I found this recently, but there are more. They are not built-in. They are not coming with STADA that you have, but you have to install them. Okay, how we install them? Using this row, you put this row in the command window to install it. All right. As in all the regression commands, not only this, but also the rec, the panel we are going to see, all have this format. We write the command, the first variable we add after the command is the y, and after the y we put all our x variables. Okay, this is the standard format. Okay, the Fermat-Macbeth of course has this comma and asks to define how many lags you want to use for the new EQS. What is that? Remember we said that in the panel regression we have always the problem with autocorrelation because it is also a time series dimension there. And if you have a time series dimension, you may have autocorrelation, serial correlation issue. And we use new EQS to correct for that. All right? The new EQS corrects for heteroscedasticity and autocorrelation. Here we have to put how many lags we believe there is serial correlation. Usually it is based on theory or you can check it. We don't check it because it's not, the results are not so sensitive to make how many lags. We use 4 or 3. Usually it has to do with the cycle with the quarterly announcement of the financial statements. Maybe a correlation due to that. So I would run this. So in my regression, you see I put on this side, put to market and to damage. Of course, you have also to add the asset growth or any other you believe must be there. The size is not found, it says. Of course, I think I forgot to calculate all this. And then we run this. You see that it takes some time because the first stage has to run 100 regressions, right? So this is why it takes some time, some seconds, not much, but it's not immediate result. So Fermat-Macbeth, number of observations, time period, so I had 102 months, not enough, but, and the average R square, that is very low, and you get the result, the report, the coefficient, standard error, t statistics, t value for dual variable, right? The other command, this one, you see, this command, the asrec, makes also other things, other regressions. So this is maybe as a command, it's only for Fermat-Macbeth, but this can do more things. So this is why here you define what regression you want. And you say this, if you run it, I think it's much faster than the previous one. You see, it is faster, and the results are the same, exactly the same result. All right, something last, because we find it when you read the papers. In the Palmer French, but also in other studies, these R here, okay, is the excess return, okay, as we say in the PowerPoint. What is the excess return? Always in asset pricing, we use the excess return, or not the raw return. The raw return is the firm return, the raw, as it is taken by CRISP. The excess return is the raw return, the firm return, minus the risk-free rate of the corresponding month, if it is monthly, right? So if you want to use to run it with excess return, that this is the correct way to do it. Then you need to bring the risk-free into the data set. Okay, how you are going to do? One way, if I am you, since I have this data set, the easy way is to download the risk-free rate. From where? From the French website. Remember, from the French website, you can go there, the risk-free rate is there. Okay, you add it, you import it. I show you how we import data. You import it from the Excel, you are going to have it. You import it here. You create a new data set called risk-free, whatever you call it, and then you merge that with your current database, okay? So you have this open, and then you go to merge that file here. Then you will have the risk-free for each firm, for each period, and then you just take the difference, all right? So this is the simplest way to do it if you like. All right, any questions? This is the time you must make questions on the project. Okay, if you don't have questions. So next week, I promise also to the others that we will see, possibly we will have some time to see again the merging thing. I want, because some of you did not achieve to have this data set, or you did not understand why we have so missings, or why should have so missings, okay, what we do with missing. So next time, possibly I will spend some time to talk about the merging of the two files, right? I don't know if it is late, but at least you will understand why we have missings here, why we use the isolation, right? All right. I'll see you later. If you have any questions.